Have you ever pondered the fabric of reality? What if the reality we perceive is just the tip of an enormous iceberg, submerged in the ocean of quantum strangeness? Welcome to the world of quantum mechanics, the science of the very small, where the rules of the game change entirely. Quantum mechanics is the branch of physics that deals with the smallest particles in the universe, like atoms and subatomic particles such as electrons and photons. It's a realm where particles can be in two places at once, where they can pass through walls, and where they can be entangled, mysteriously connected over vast distances. To begin, imagine a particle. According to classical physics, this particle would exist in a single place at a single time. But quantum mechanics throws this idea out of the window. Instead, it proposes that a particle exists in a state of superposition. Essentially, it can be in multiple places at once. It's only when we measure or observe the particle that it chooses a single location. Now consider the phenomenon of quantum tunneling. This is the ability of a particle to pass through a barrier that it should not, theoretically, be able to pass. It works like magic in the quantum world. A particle approaches a wall, and instead of bouncing off as it would in classical physics, it disappears and reappears on the other side. Then there's entanglement, one of the most mysterious aspects of quantum mechanics. If two particles become entangled, they become deeply linked to each other. Change the state of one particle, and the other changes instantly, no matter how far apart they are. This spooky action at a distance, as Einstein famously called it, has been proven in numerous experiments, and remains one of the most fascinating aspects of quantum mechanics. And then, there's the concept of wave-particle duality. In the quantum world, particles can also behave like waves. This means that particles like electrons and photons can exhibit properties of both particles and waves. A prime example of this is the famous double-slit experiment, which demonstrates that light and matter can display characteristics of both waves and particles. Quantum mechanics challenges our everyday intuition. It's strange and counterintuitive, but it's also incredibly successful. It's the theory that underpins much of modern technology, from computers to lasers, and even the atomic clock. So, to summarize, quantum mechanics is a branch of physics that deals with the smallest particles in the universe. It proposes that particles can exist in multiple places at once, a state known as superposition. It also suggests that particles can pass through barriers in a process called quantum tunneling, and that particles can become entangled, influencing each other over vast distances. Quantum mechanics might be strange, but it's also one of the most successful theories in the history of science. It's the theory that has revolutionized our understanding of the universe and continues to shape the future of technological innovation. So next time you ponder the fabric of reality, remember that there's a whole lot more going on beneath the surface.